Hello, welcome to this day 5 e-learning video. We are talking about properties of logs. And so Friday, our last lesson, we talked about like what the meaning of a log is. And a log means, hey, what do I need to raise this base to get this input, right? And so there's properties of logs, just like there's properties of exponents. So we're going to hit first the general properties of logs. General properties of logs, here's one. Log base b of b. If the base and the input match, it's always going to equal 1. Here's why. By the definition of a log, this is saying 3 to what power equals 3? Well, 3 to the first power equals 3, right? And as you can imagine, if it was log base 5 to the first power equals 5. So it doesn't matter what these numbers are, but if they match, that log always equals 1. It's just a general property of logs. Next, log base b of 1. Doesn't matter what the base is. If the input is 1, that log's value will equal 0. Here's why. By the definition of a log. What if we had log base 5 of 1? A log is saying 5 to what power equals 1? Well, anything to the 0 power equals 1. That's why anytime the input is 1, that log's always going to equal 0. And so those are just two general properties of logs. Now, the next 3 things are the legit properties of logs that you'll be using often. So first, the product property. Log base b of m times n. They call it the product property because if you have 2 inputs, or if you have 1 input where there's 2 values being multiplied, you can expand that into log base b of m plus log base b of n. So with multiplication, addition is sort of like related to it when it comes to logs. Here you have the condensed version. Here you have the expanded version. Now you could go both ways with it. So if the directions say to condense and you're in this form, you need to look to see first that they have the same base. And if they have the same base, if you are adding the 2 logs, you can combine them by taking the inputs and multiplying them. That's condensing. Likewise, if you needed to expand, you could just go the other way with it. As long as there's some multiplication going on in the input, then you can expand that into 2 logs by splitting up the inputs and making an addition with the same base. Okay, so for example, take a look at these 2 logs. If the directions say to condense, well, we could put those together because these have the same base, log base 2 of 7 plus log base 2 of 4. This plus is associated with multiplication, which means I can condense by multiplying my inputs. 7 times 4 is 28. This is my condensed version. Notice it has the same base. Or I could expand if I want. Expanding is kind of, it's weirder because, well, take a look at log of 45. For me to expand, right, I need 2 things that are being multiplied, which means that you just need to come up with 2 factors of 45. Give me 2 numbers that multiply to 45. Here I chose 5 times 9. Don't choose 45 times 1 because that won't really give you any information, because any log with the input of 1 equals 0, right? So choose two factors that multiply to this. I chose 5 times 9. So basically this is the same as log of 5 times 9, and now I can expand it. I can break up the 5 and 9 with addition. That equals the same thing as log 5 plus log 9. It follows the product property of logs. Make sure you got a notebook, write these down. 1, 2, 3, 4, write these down because you're going to use them often. All right, next, number 4 here, the quotient property of logs. So the quotient property, hold on, give me a second. Go ahead, get that first. All right, the quotient property of logs says that if you have in your input here, if you have two things that a fraction, or if they're being divided, right? You can expand that using subtraction. So division is kind of tied in with subtraction. They relate together with logs and properties of logs. So here's the condensed version, right? M divided by n. Notice the base is b. I can expand that by taking the input that's on the top of this fraction and putting that in its own log. You have to start with the thing that's on top of the fraction, because order matters with subtraction. Order also matters with division. And so the thing on top goes first, okay? Log base b of m minus log base b of n. So this is the condensed version. If it's division, I can expand using subtraction. Here's some examples for you. Suppose we have log base 3 of 24 minus log base 3 of 8. Well, if my directions say to condense, I notice first they have the same base. They have to have the same base for you to use these properties. Since they have the same base and this is subtraction, well, subtraction is related to division with properties of logs. And so I can combine these, I can condense them by just dividing the first one by the second one. The inputs, 24 divided by 8. Well, 24 divided by 8 is just 3, right? So notice I kept the same base here all throughout. So this is the condensed version of this expression, log base 3 of 3, which, I mean, if we had to evaluate it, we should know that that equals 1, right? But we didn't have to evaluate, it just said condensed. What about expand? All right. Again, this is tricky because if you have log base 8 of 4, well, it's not in this form. You don't have division, right? And so you need to come up with two numbers that when you divide them, it equals 4. Notice, 16, hold on. Oh, I get that frisbee. 16 divided by 4 is 4. So I just replaced this 4 with a fraction, something that I came up with. This fraction does need to equal 4, and I expanded once I came up with these two numbers, okay? So now that's log base 8 of 16 first minus log base 8 of 4. This is the expanded version of what we started with here. You could have there are so many options. How about you could have put in here 32 divided by 8, because that equals 4, right? So many options for expanding. This option, when you have a variable, it's a lot easier because I already have a fraction here. And if I have to expand, I notice quotient rule uses subtraction. The one on top goes first, log m minus log 7. This is the expanded, or the expanded form. All right, so next is the last property, the power property of logs. It says that if you have log base b with inside your input, if you have m to the n power, it's called the power property because you have an exponent in the input of your log. If that's the case, then you can expand by just bringing, and this one is easy. I love this one. It's the most easiest one. By just bringing the n, the exponent out of the log and just putting it right out front. It becomes multiplication. So the expanded version is just you bringing that exponent out front and making it multiplication. So simple. Here's the expanded version. You could go the other way with it if you wanted. You could condense. You could condense by just bringing n inside the log and it becomes the exponent. And so here, let me give you some examples. First, condensing. Well, condensing means 5 times log base 4 of 2. Means to bring the 5 in the log, it becomes an exponent on the input, and 2 to the 5th power is 32. So then this is log base 4 of 32. This equals the same thing as log base 4 of 32. This is the condensed version though. What if you have a fraction out in front? Well, it works the same way. You bring the thing out front, you bring it into the log, it becomes an exponent, But here you need to remember what a fractional exponent means. 8 to the 1/3. Now you could use your calculator if you want, but 1/3 power just means this is the cubed root of 8, which is just 2. So this condenses to log 2. What about expanding? Oh, expanding is even easier. You just take the exponent, bring it out front. 7 times log base 2 of 8. That's all. What if you have an expression? Well, you just take the exponent, bring it out front. Now it has to go in parentheses because it's this whole thing times the log. So you take this, bring it out front. X plus 1 equals, or times, log base 3 of 4. And so that is the power property of logs. Next, we want to put it all together because that's what you're going to have to do for your homework. You're going to have to use all the properties, and you're going to have to first condense everything. Then, if you need to evaluate, I suggest you use the change of base formula to evaluate. And these are the directions on your homework. Condense, well, in one section, it says to condense, then use the change of base formula to evaluate. Hopefully you remember the change of base formula. If not, I'll write it here for you. Log base B of A equals, you can use any, we're just going to use the common log of A divided by log of B. We changed the base, now both of these have the common log. You want to do that because you can use your calculator with common log. Let me adjust the camera real quick. Bear with me. Okay, here's some examples then. Here's some examples. I got 3 examples for you. Now they look very intense. We just need to break it apart piece by piece, okay? Here, if we start with this expression, and my directions say to condense, then use change of base formula to evaluate. Well, I first need to condense. So I still use my rules, PEMDAS, right? First you need to do parentheses, then exponents, blah, blah, blah. Well, here it's addition or subtraction. When you have addition and subtraction, they're on the same level. And so you just want to first do, you work from left to right. So first I'm going to combine these using, well, addition is tied with multiplication, right? So I can combine these by multiplying 15 times 4. 15 times 4 is 60. So I combine these two, I put it in the same log. Notice they all have the same base, which they need to have. And now I've combined these, and this is what I got. Now I can subtract this piece. Well, subtraction is associated with division, right? So I can combine these, I can condense this by dividing. 60 divided by 6, which is just 10. Now, this is the condensed part. I've just condensed it. Now I need to use my change of base formula, which means that I take the input, common log of the input divided by common log of the base. And now I type this whole thing into my calculator. I type this whole thing into my calculator. You'll have to round to 4 decimal places, okay? This equals that, which means that this expression here equals that. That's the first one. So what did I do? I condensed first, I used the change of base formula, then I evaluated. What about this? I have 3 times log base 2 of 4 minus log base 2 of 32. Notice they have the same base, which we need. Now, first, order of operations says, before you do subtraction, you want to multiply, which means that we need to bring this 3 into our log first. Remember, that's the power property. It says you can condense by bringing the multiple out front into the log, and it becomes an exponent. So this becomes log base 2 of 4 to the 3rd power. 4 to the 3rd power is 64. So I'm just working my way down. This guy, he just tagged along. There was nothing to do until I condensed this first piece. Now I can subtract these two. The quotient rule says when you subtract, you can divide. So I can divide 64 by 32. 64 divided by 32 is just 2. So I have log base 2 of 2. Now, I could use the change of base formula here and type it into my calculator. My calculator will tell me that it's 1. Or I could use that general property that says, well, when the base and the input match, it just equals 1. So the value of this expression does just equal 1. And I'm done here. I condensed. Well, I didn't have to use change of base, but then I evaluated. Okay. Give me a second. Get that stick. All right, last problem. This one, a lot of stuff going on. Just break it down into pieces. Order of operations says you want to do parentheses first, right? So notice they have the same base. I'm going to evaluate this stuff in parentheses, or I'm going to condense the stuff in parentheses. When you add, you multiply. 8 times 27 is 216. So I just condensed these. And now I'm going to bring this into my log because this is 1/3 times this log. I'll bring it in, it becomes an exponent. And now I put this into my calculator. I'm trying to like simplify this, right? 216 to the 1/3 power, that's just 6. You could type that in your calculator. It's basically the cubed root of 216. Hey, get out of here. You're in the way, kid. Dogs, right? So now I have log base 5 of 6. I didn't have to do anything to this piece, so I just brought it down, brought it along for the ride, and now I can combine these two, I can condense. When you subtract the logs, you divide. 6 divided by 3, you divide the inputs, right? Well, that's just 2. So now I have log base 5 of 2. Now I could use my change of base formula. That's common log of 2 divided by common log of 5. I type that into my calculator, and I round to 4 decimal places. That's my answer. Make sure if you have any questions that you ask in the discussion. I think we're gonna do this type of stuff at least for 2 days. And so I just gave you everything now. You'll have to maybe rewatch this video. Make sure you wrote down all of the properties because you're gonna use them today and tomorrow, all right? Soon we're gonna have a quiz. We will have one this week. So make sure you know how to do all this on your own and you know how to do it in a reasonable amount of time. Okay, hasta la vista, baby.